When we talk about atoms, we also talk about something called isotopes. Now here's the definition of an isotope. Atoms of the same element. So that means all atoms of the same element would have the same number of protons, right? Or the same atomic number. So atoms of the same element that have a different number of neutrons. So what that means is if you have a different number of neutrons, it means you have different mass numbers. So originally, when they first thought about atoms, they thought that all atoms of the same element were identical. So they thought if you had a carbon atom, all carbon atoms would be the same. They'd have the same protons, same electrons. But here's the thing, they really didn't know quite about neutrons. So if you remember from a previous video, it's the protons and the neutrons that make up the mass of an atom. So when they started being able to to identify or measure the mass of different atoms, they realized that some atoms of carbon had different masses than other atoms of carbon. So how that could be explained is by this third particle called the neutron, which originally they didn't know about, but this third particle called the neutron. So, and neutrons, even though the protons and electrons for an atom are the same, the number of neutrons can vary. So that's where we come up with the idea of isotopes. So here's some examples of isotopes, and then I'm going to come back to the isotope symbol that's above it. So when I say isotopes, this is kind of what it means right here. These are isotopes of carbon. So when we look at them, all three of them, they're carbon. So it's carbon, and this line right here, whoops, sorry, sometimes the iPad does weird things. That line right there is a dash. Okay, so it's carbon-12, carbon-13, carbon-14. So what we know about carbon is all carbons have 6 protons. Now I've memorized that because of experience, but if you didn't know that carbon had 6 protons, all you have to do is you find carbon on the periodic table. I think I have a periodic table on the next page. Yep. So I'd find carbon. Here's carbon right here, and there's the number 6. So I know that carbon has 6 protons. So carbon has 6 protons. See how they all have 6? Because they're all carbon. And then we would know, because protons and electrons are equal for an atom, they would all have 6 electrons. But what varies, because they all have different masses, is the number of neutrons. Now this number of neutrons, we have a hint with these numbers right here. These numbers behind the dash are the mass numbers. So it's very, very, very common to write, when they're trying to let you know about the mass number, to say carbon, the element name, dash, and then a number. And I wouldn't say, if I was talking to you, I wouldn't say carbon-12. I would just call it carbon-12. Okay, and that 12 is the mass number. So from the mass number, I can figure out these numbers of neutrons, right? Because the mass number equals protons plus neutrons. So if I take the mass number and subtract the protons, I have the neutrons. So in this case, the mass number for the first one, so it's the mass number would be, this one right here is 12 is the mass number minus 6 protons, and that gives me 6. On the second one, the mass number is 13. It's carbon-13. So 13 minus the atomic number, and that equals 6. And then the mass number is 14. So 14 minus the atomic number, 6, is 8. So if we know the element and the number and the mass number, we can figure out the number of neutrons. Now that brings me back up here to this isotope symbol that's up here. So you see here, there's 2 ways we talk about this. There's little notations. It's either isotope symbol or isotope or isotopic notation. And in this case, we have the mass number, which if you review the previous video, they use a symbol A. the atomic number, they use a Z. And then here's the element symbol, which is they use an E. So for example, here's our examples here. So all of these are carbons, so you notice they all have C, right? Also, since they're carbon, this number down, the lower number is the atomic number. Well, they're all element 6, so then they put the 6 here. And my pen is probably too thick for what I'm doing. And then the mass number is on the superscript, sorry. And so there's a 12, a 13, and a 14. Let me try another one because I know I've kind of written all over this page trying to help you understand. But let's say I have a chlorine dash, so chlorine 35, and a chlorine 37. Okay, so I can get my periodic table, turn over, and here's chlorine. So I know there's chlorine, it's Cl, and its atomic number is 17. So that means the symbol, you have the symbol, they would both be Cl because they're chlorine, and they would both have their atomic number written in the lower one as a 17. I found that on the periodic table. So just knowing it's chlorine, I can find those two things. Then to find the mass number, well, in this case, it was given. So this is 35, and this one is 37. So right here and right here, I've written the isotope notation or the isotopic symbols for these two, for chlorine 35 and chlorine 37. Now, I also could have, so let's say they give it to me in the reverse. You can probably tell I like changing colors. All right, so let's say they give me the symbol. Let's say it's 195 78 PT. And the question is, they want to know the atomic number, the mass number, the protons, the neutrons, and the electrons. So let me list those. Okay, so atomic number. Now you could find this two ways. I suppose you could find platinum, which is PT on the periodic table, but the atomic number is also this lower number right here. So platinum must be element 78. So that tells me the atomic number. Now I want to know the mass number. Where can I find the mass number? Well, remember the isotope notation. This number right up here, 195, is the mass number. Now, let's say I want to know how many of each of the subatomic particles. So let's say I want to know the number of protons. Well, I know that the atomic number and the number of protons are equal. So if the atomic number is 78, then this also has to be 78. Now, if I want to know the number of neutrons, when you know the mass number, and I'll kind of do this underneath, maybe I'll change color so it doesn't look like I'm too much. So if you take the mass number, which is 195, and you subtract out the atomic number, or the proton, sorry, which is 78, then 195 minus 78, and I'm cheating and looking on my calculator, is 117. So this number is 117, and so that difference there tells me, I totally changed colors. 117. Oh, come on, computer. Sorry. And then, what else could I know? Oh, the electrons. And then the number of electrons. Remember that the number of electrons equals the number of protons. So this would be also 78. So one thing you want to practice and try to do examples, you want to be able to take the names and if you know how many protons, electrons, and neutrons and get the symbol, like we did kind of in the first problem, or if you know the symbol, you want to be able to kind of get the other information from it. So that's something you can practice. Now, another thing that we want to think about in terms of elements is something called its atomic weight. An atomic weight down here is related to the mass number. So if you remember when we're talking about the atom, it's the protons and neutrons that make up the mass, because the electron's mass is negligible. So it doesn't weigh very much. It doesn't really contribute. So it's just the protons and neutrons. So the protons and neutrons together make up the mass. But here's the thing, like in this example here, there's a chlorine 35, which would weigh about 35 AMU, and a chlorine 37, which would weigh about 37 AMU. So when I want to go to the periodic table, what do I write? Like, do I write 36 because it's in between, or how do I do it? So what they did is they take what's called a weighted average of all the naturally occurring isotopes. So in a weighted average, if we know that chlorine 35 is about 75%, then that will count more than chlorine 37, which is about 25%. So we weight it, the one that has the more, will contribute more to the mass. Now, in some classes, it would be important, and they show you how to calculate it. In your textbook, they have an example of how to calculate a weighted average. But what I want you to know is that I want you to know the definition, that the atomic weight is not the same as the mass number, that the atomic weight is a weighted average of all the naturally occurring isotopes. And I also want you to know that we can look up the atomic weight, because we're going to need it in chapter 5 in a later chapter, but we can look up the atomic weight on the periodic table. So when we look, and I'm going to I'll pick an example. It's really small here, but so nitrogen right here has an atomic weight of about 14.01. Now, and the units would be AMU. Now, in general, this periodic table goes to at least 3 past the decimal. In general, I like to have 4 significant figures in my masses, so at least 4 digits, not 4 past the decimal, but a total of 4 digits. So carbon, you can see, is 12.01. Hydrogen, if you look on here, up here, is 1.008. And these are all. So this would be the atomic weight of the atom. And remember, it's an average of all the isotopes. So that's what this number is here. We do not have to memorize atomic weights. Atomic weights, we can use our periodic table when we need them. And in future chapters, we will need to take a look at them.